A sewer system that ignores its engineering constraints will eventually fail, often resulting in waste backing up directly into a building's foundations. Success on the board exam requires shifting focus from memorizing numerical values to identifying the physical boundaries where those values apply. We are the staff instructors from JCB EduBuild Solutions. Our firm was founded by engineer James Bolo to provide the technical clarity needed to master complex utility systems. Today's objective is to lock down the specific regulatory and physical constraints of house drains and house sewers. To anchor these metrics, we are building a mental blueprint, a functional spatial model that places every rule in its subterranean context. Connecting the regulatory text to its physical purpose provides the clarity needed to navigate non-standard exam scenarios without second-guessing. Professional licensure is built on this transition from the page to a functional understanding of spatial triggers and hydraulic thresholds. We begin at the exterior wall. Determining if a pipe is a building drain or a building sewer is a matter of geographic demarcation. This is our first spatial trigger. The building sewer officially begins exactly 0.6 meters from the outside face of the structure's wall. Section 1201.1 validates the starting point, establishing the legal definition of the building sewer as it leaves the structure's vicinity. This 0.6-meter mark creates a clear jurisdictional handover point, transitioning the system from internal plumbing to external infrastructure. Once the waste is outside the building, connecting to a public main is often a legal mandate rather than a design choice. A public sewer is legally considered available if it is located within 61 meters of the building or its drainage facility. Section 1201.4 codifies its threshold. Beyond this 61-meter limit, the code permits the use of an approved private sewage disposal system. Note the rule for subdivisions. Splitting a lot already served by a public sewer does not exempt new parcels from the connection requirement. There is a legacy exception for existing single-family dwellings that were already connected to an approved private system before a public main was built nearby. These systems can only remain if they are properly maintained, present no nuisance, and have explicit written permission from the administrative authority. Our model is now governed by two spatial triggers. 0.6 meters defines where the sewer starts, and 61 meters defines where the waste must go. The building sewer is an exclusive corridor. It is not designed to accept every type of liquid waste on the property. The most critical ban is on stormwater. Rain and surface water must never enter the excreta drainage system. They require their own independent pipeline. Furthermore, raw effluents from cesspools or septic tanks are prohibited from entering a building sewer that leads to a public main. Commercial food waste grinders are also restricted and cannot be connected without explicit permission from the administrative authority. Sections 1202.2 through 1202.4 specify these exclusions, ensuring that rainwater, septic sludge, and commercial solids are kept out of the main sewer. Hazardous materials require a different protocol. They must be collected in a watertight holding tank for periodic removal and off-site disposal. These bans protect the system. Public mains rely on specific chemical balances and hydraulic volumes. Storm surges or septic sludge can destroy that equilibrium. Ultimately, these protection rules prevent the physical and chemical degradation of public utility infrastructure. We'll now move to the cross-section profile of the sewer trench to examine the hydraulic gradient. Sizing starts with a bedrock minimum. The building sewer must be at least 150 millimeters in diameter and never smaller than the building drain it serves. Gravity flow requires a baseline slope of 2%, or 21 millimeters per meter, directed toward the point of disposal. Section 1205 confirms the sizing minimums, while Section 1206.1 establishes the 2% slope as the baseline for the system. However, the code provides an exception matrix for scenarios where a 2% slope is physically impossible. When structural constraints or excessive street sewer depths occur, the code permits specific reductions in gradient. Under Exception 1, pipes with a diameter of 102 or 152.4 millimeters may drop to a 1% slope, or 10.5 millimeters per meter. For higher throughput, pipes 203 millimeters and larger may drop to a 0.5% slope, or 5.3 millimeters per meter. These slope reductions are not discretionary. They must be explicitly approved by the administrative authority. This hydraulic trade-off works because larger pipe diameters allow waste to maintain the required scouring velocity at shallower angles. Sizing and grading share an inverse relationship. As the size of the pipe increases, the allowable minimum slope decreases. Our compliant mental blueprint is now complete, from the structure to the main. By anchoring your knowledge to these spatial spheres, 0.6 meters and 61 meters, and the hydraulic matrix, the system's requirements become predictable. Maintaining scouring velocity and protecting public infrastructure is the core intent of these regulations. This physical purpose creates a predictable logic for every rule. On behalf of the staff at JCB EduBuild Solutions, we wish you clarity in your final preparations. We continue the work of our founder, Engineer James Bolo, in preparing the next generation of Filipino engineers for professional practice. Trust your foundational logic and finish strong.